So I guess you can see my screen and we've started the recording. So today's using modularity in Python and using Jupyter, actually basically using platforms and modularizations and basic concepts while doing some statistics and while doing some Python programming. So this is the tutorial about that. So from the first place, what do we mean by modular programming? So we expect you to follow a modular style of writing your codes and programs. So what do we mean by that? So the big picture, for example, let's try some some imaginary way. Okay, so you have a massive or complex software project that is big. So it might be data analysis pipeline, a web application, or scientific simulation. So trying to build this as one giant continuous block of codes is like trying to sculpt a detailed castle from a single undifferentiated lump of clay. So the concept is if you're trying just to build a complex or a big project, so just doing one thing or doing one object or not classifying the tasks for a different part of the software or for the project, it is going to make the system or the software that you've built a very complicated one. So it is not going to be easily managed. So one system, especially when it comes like, even if it is a small, but this concept would be more important if the project is large or big. So, but even if it is small, so you need to try to build different components as part of that project or as part of that system. Okay, so this is where modular programming comes. It's fundamental software design principle that involves breaking down large program or system into smaller, manageable, and independent units called modules. So you can just think of these modules as self-contained building blocks or components. Meanwhile, let me say something. So if there's a question, if you guys are not hearing me or if there's some problem, since I've shared my screen, I might not be able to see your comments or something. So you can just open your mic and talk, okay? Okay, so proceeding. So consider building here a Lego castle. So you don't start with one huge piece of plastic. This is kind of more metaphorical way of explaining what modular programming is. So it is just you need to build different modules or different small bricks or small individual functions or entities that will explain or that will help the full system as one of as a building block. Okay, so this is the concept of modular programming. So systems are not going to be standard. Are not going to build or are not going to be depend on specific thing. Rather, they're classified in different things. So each of them will depend on, for each functionality, they will depend for a specific function or a specific part of the program. So what is the benefit or why modular programming? So the first one is maintainability. I guess Nani Chakabara, I guess your mic is open. Okay, thank you. So the first one is maintainability. So what do we mean by maintainability? It is easier to understand, debug, and update specific part of the code. So let's say some part of your code or some part of the system is not working, and if that specific part is, you know what, there's the EDA part, the data exploration, and you're trying to predict something based on the data. So like there's the EDA and there's the a model training, and then there's the prediction. Okay, so what if you have faced a specific problem on the EDA? You're not supposed to change all of the system, or you're not supposed to check for all of the code base. Rather, you know where you have done the EDA, since it's modularized, so it is going to be easy to maintain. The other is reusability, which is module can be reused across different projects without rewriting. So modules are independent. They might be independent of the system itself. Okay, so they're just a function. So those functions can be used in different projects, in different related projects. So you can just reuse that module for another project, and maybe you can just change the data or change another related things. The other one is readability. It's cleaner, more organized code, improving collaboration. So if there's another person that wants to understand your code and that wants to collaborate, so it is going, the readability will make this will make it easier for the person to read, to understand, and then to put their effort or to put their part. The other one is scalability. So if your system is about to grow and to be, to be a large project. So modular projects are easily are easily adopted, or you can make your project scalable to a large extent. And the other one is testability. So there's always a unit test or a test, right? So when testing your project, you can just taste the specific different parts of the system, since it's modular. So you can just make a different taste uh, different for the different part which have specific functionality. So these are the benefits or the reasons why we usually use modular programming. So how can we achieve that? For example, we have decided to use modularity in Python. So what are the measurements that we use or that we take? So the first one is the fundamental unit, or the fundamental unit is the module. So in Python, the most basic building block of modularity is a module. So this thing, it might be, some of you might be familiar with this concept, so some of you might not. So we're all always trying to take the average. So like this might be, common concept for most of you, and it might be new for most of you again. So yeah, just that is the average. So the most basic building block of modularity is the module. Literally the page or the scripts, we usually call them the Python scripts that we name them like x.py, y.py. Okay, the name of the script will be like that. So that is called a module in Python. So they will include most of the basic building blocks of which is they are standard Python file. They contain definition of functions. So if we have different defined functions, we can include them, or we can collaborate them in a class. And then variables and other executable statements that you want to reuse or organize. So that the main idea or the main part of modularity is putting your module in a specific part, so that now those are the things that we have said they can be reusable. They can be they will include the function, which is which will contain most of the actions or most of the works that are going to be done by the system. And then the different functions will be collaborated to one class, and then there are variables. So the module, you can think of a module as a toolbox containing specific set of tools, like the function class for a particular job. So the basic or the first thing that we should know about that needs to come to our mind while talking about modularity in Python is the module. And then organizing related modules. So as our projects grows, there are going to be many modules, right? Not a specific module. So we will take different type of modules or PY files inside one folder. So we will also keep the module itself organized. So now that is called a package. So package is essentially directory. It's a folder, okay, that will contain different or multiple modules. So in order to let the system know that this is a package, we will include the init.py file inside the folder. So this is a package. This is the package part. So like there are packages that we know, right? The pip install packages that we are related with. So those are one forms of package. Also, these are the packages that we usually build while building our projects or system. So they will allow you to create a hierarchical structure of your code, grouping related modules together. So it will create a clean hierarchy. The other is the import statement. So now we have created a module. We have accumulated different scripts inside or different scripts inside our folder. So now we call them a package. So now we will use the import statement, which is bringing the code together. So once you have modules and package, you need a way to access their contents from other Python scripts or notebooks, right? So the import statements or they will come here. So importing the module name, importing the class. So like import module name will directly import the entire module. So you then access it to contents using module name.function or module name.class name. So we can see this later. So the import statement will, if we want to import the whole module, then we can just imagine module name. This module name is the name of a script, module name.py. We have a script called module name.py, so we can import the whole module name. And after that, there are different functions inside module we've said, right? So we can access the functions using module name.functions or module name.class names. So from module name, also from module name, import function name or class name. So this will import specific item directly, which is called function name from the module name. So, okay, now we're not importing the module name or the module directly, but we are importing specific function or class inside that module. So the second command can be accessed for that. So now we have built a module, we have built a script, and also we're connecting our script to other notebooks or to our workspace. And modularity in action. So already you've been using different type of modular programming language, right? Like math, OS, import system. So they are the standard library, okay? Python comes with a standard library, collection of pre-built modules for common tasks. That is what I've said before. So they are already pre-built modules, so you can just include them for specific tasks that mostly we use those types of libraries or modules. So in order to keep the modularity, we usually do this. So if you've seen since you all have been in week 0, so one of the tasks that we evaluate is the modularity of your code or your repository. So the first one is the project root directory. So that is the main folder. And then inside that, we will include the source or the lib directory for your application source code or modules, or we can also replace this using scripts. So that is the module. Okay, so we will include our modules inside a folder called script or source or library. So, and then there's the data, which is for the input data. There's a notebook for our Jupyter notebooks. And then there's the test directory, folder for unit test, and the main.py will be an entry point of your application. Okay, so it is a script that is not written inside any folder, so that will help us to write an entry point if we're going to serve our program, or if we are going to use Fast API or another API serving Flask. So that would be, so here on main.py, we're almost going to call most of the functions that we're going to use to build the system, and this will prepare an endpoint for the works that we've done. It will be point of your application, or so now we can just serve our modules as an API inside the main.py. So this is basically the structure of our Python projects that we mostly follow. So when we say Jupyter notebooks and modularity, so like Jupyter notebook, usually it's just a notebook. So the strings is interactive exploration. So we can write the same code as a module instead of a notebook, but it will not give us the chance to interact with or to explore with our code or the output of our code. So it is mostly used for data analysis workflows, and the weakness will lead to notebook. Like if not managed, hard to use code, is difficult for version control. Sometimes, if depending on the notebook or the place that you're using, you can just directly use it on VS Code, so that will be easier. So the problem will be mixing presentations, experimentations, and core logics in one notebook. So also we would be somehow careful to manage the things that we need for presentation, the things that we need for our exploration or experimentation differently, okay? So import script. What is the solution to separate core logic into Python scripts? The first one is import scripts into Jupyter. So we have seen how to use the import statement in order to import the modules that we have built. So we use import statements to bring your custom modules into Notebook. Jupyter for analysis and visualization. It is really call functions from your scripts, and it would be nice for exploration and visualization. So yeah, load these functions will be the essential for live development with imported module in Jupyter. So we can use, or first start using Jupyter, start using the notebook, and we can use the auto reload and the loadx auto reload in order to, every time we have made some change, we don't need to reload from the beginning. So those are really related with the first one. So best practice of what are the best practice? So clear module responsibilities, meaningful namings, the naming of your modules, functions, classes, everything. You need to be careful about them naming. So document your code for clarity and maintainability, which means you need to prepare the README and the other stuffs. You've seen this on the while learning about the GitHub. Avoid global states like keep functions pure and independent from each other. So that one function as much as you can. It can happen, but like creating a loop of functions. So one function is calling the other function is being called in another function will sometimes create a complication. In the version control, of course, use Git to track Git, and virtual environment are also, they will isolate project dependencies in Python, so they're one of the most important things that we use. So let's try to apply modularity in life. So maybe do you have a question on like on the concepts? Now we can just see the demo, or we can just apply slightly how to use modularity using demo. Before that, if you have some question, you can ask. If you feel like your question will be answered on like the demo part, then you can keep it. But are you good with the concept wise? Is that clear? Okay, Nabil, thank you. Fantahun, you can go.
Am I audible?
You are audible, yeah.
Okay, I have one question. Is it possible to import the packages and access all the modules inside the package, or we need to import all the inside modules, which is a better option?
I didn't understand the difference between the two, or I didn't understand it. Like, is it possible to import the modules inside the notebook?
Is it possible to import a package and access the modules inside that package, or is it which is a better, or it's
okay? I guess rather than installing it inside the notebook or importing it. Is that the question? Is that the question? I'm sorry. So we usually, let me just clarify things. We usually, if the modules, or yeah, if the modules are modules that we've created, if they're not the standard library part of the Python, then yeah, it is really the good idea is, or the good way is to just create them inside another. That is why we have shown about the module. We just create them inside a module or inside another folder, and it is the best practices to import them and use them, so that if we have a related program or a related project, you can just do the same. If you want that functionality part of the code, then you can also import that one and you can reuse it. So it is, instead of creating your any type of functionalities, the functionality itself inside a notebook or in another part. So it is, the best thing is to make it as modular as we can, or as separated as we can.
Thank you.
Okay. Okay, so somehow I will try to make it related with our project. So let's say in this week project, we're trying to make an analysis on stock market data, right? Like we have two data, two form of data: the raw analyst ratings, which includes both sales fee hikes, so which includes, and not the Apple actually, specifically the industry specified data or sales fee data. Okay, so here so I guess you just took the introduction for the challenge. You are familiar with the data, I believe. So this is specifically for some company. This is for Apple, and this one is for the news, right? So this headline was published in this time, and this is the URL in this date. So like now we are supposed to relate the stock market, the news, and how are the news affecting the stock market, right? So I guess you all are familiar with the concept, or what are you doing? So the first thing that you need to do is like analyzing the data. Also the ADA part we have seen on week 0, and also you have seen how to make data analysis on stock market data. on the data analysis on stock market data on your previous session. So those are the data. And we are having the data here, and then inside the notebook we have the notebook. So if we want to do the EDA, then inside the notebook. If we want to make some prediction on the model, then still inside the notebook. So this is the notebook, and this is the script, which is which is containing the module. So in order to make this script module, so we have said that we need to include the init.py file, right? So this will make the system to treat this folder as a module or as a package. So this is going to be empty. So inside it, we have two .py files, the quantitative analysis and the sentiment analysis. So it is just, so now you need to be careful, or you need to be, I need you to focus on the concept, right? So here, the last one is the stock market, which is the virtual environment that I have created. So the first thing, see, it's also activated here. So anything I'm going to install here is going to be installed inside the virtual environment stock market. So there are going to be different folders and different scripts that you're going to create for your project, depending on what is expected in the challenge document. So for now, these are going to be the basic format. So let's see on the financial forecasting part. So the first one is, those are the standard libraries that I have mentioned. So we have stated the paths. One of the problem in Python is you're going to face, probably you're going to, there might be some problems related with paths. So now we've stated our path, so we can join, this folder is joined, or this folder can access the folders, like this is inside notebook, so it can access the data, the folders like data scripts, because we have we're out, or we have gone back in one state, right? It was inside we are inside the notebook folder. So two dots will make it out, like we now are parallel with the with data, with scripts, with stock market. So we can easily access the name code data, we can easily access the name code scripts. So then we have imported from scripts, sentiment analysis, article data analyzer. So let's check scripts. Inside scripts, I have mentioned, I have two modules, the quantitative analysis and the sentiment analysis, okay? So starting from, we can just start from the quantitative analysis. So here, there are different functions. What I mean by function previously, I mean, we understand functions. I have one class called the quantitative analysis class. So you might include different things or different functionalities in this class. So sometimes it might not be even related with, you might not get you might not use all of, in this time, you can do, it is just an example. You can just define different type of functions here, but you might not also use all of the functions. So since it's related, if you have defined just some functions related with this type of project, you are not supposed to use all of them. You might use them another day, or in another function, or in another, while scaling the project, or in another related projects. So here I have a function to change the date column, or into the date column into a datetime format. Okay, so another function to set index, or to prepare it in a data frame index. Reset index to include the data's column. Different type of, we've included different type of functions. So this is, you might use this type of functionalities while after installing KLib, and to calculate analysis indicators, plot analysis to plot is, usual concept. So you might need the plot functionalities to plot different type of functions. But maybe here we have specified the column names, because we know the data. This type of functions might not be reusable, but since the only point of modularity is not to make it reusable, so there are different type of functionalities that will help us to make a quantitative analysis in our data. On the sentiment analysis part also, we have a class called article data analyzer. Here we're going to analyze the article. So again, there are depending on the data, or and in what are we thinking to use, what are we thinking to do in the data. The first one is formatting the datetime, say datetime index, analyzing the headline, so like the links of the headline, counting the headlines, different type of analysis. Like there are different publishers and the number of publishers, like this specific publisher had published this amount of this number of news or articles, and making the sentiment analysis. We're going to do we're going to analyze the sentimental value, and we're going to evaluate them to positive, negative, right? So I'm not going to share this function though. So you can just put the sentiment analysis function here, also the headline analysis. So what type of analysis that are you thinking to make on the headline? So the point is, there are, depending on our project, there are many functionalities that we are supposed to do. So you can just define them in one of your scripts. So now the first step might be the financial forecasting. Okay, so we have imported the, before importing the data, we can just see here. So from scripts, this is the type of importing method that I have mentioned earlier. From scripts and sentiment analysis, we are importing article data analyzer. So scripts is this folder, right? The scripts. So, and the sentiment analysis is the specific module, which is the sentiment analysis. So the article data analyzer is the class that we have created. So here you can see that while clicking on this, it's class called article data analyzer, and we'll the clicking it will take me to the where it is, defined. So it is defined inside here, and the whole thing is that what we have shown. Okay, it's everything is aggregated inside one class. Okay, so we've imported this. We've imported the main libraries that we usually use. So it says downloading an LTK resource. So this type of resource might not be sometimes like inside an LTK you're going to use. Okay, again, this is another concept, but yeah, inside some library, there are many other packets that are dependent on that library. So you need to make sure that sometimes the downloading those things might not be recognized. So you can just use different type of methods. So every time running the sale here, we're downloading those libraries if they're not downloaded. So if it is downloaded, we can just we can like quite is true in this case because we don't need to see the process. So downloading specific packets or libraries will have many outputs, so we don't want to see that. So we're just seeing the print statement. So every time we run this class, those libraries are installed. Of course, you can just install them properly on inside your virtual environment, but if that is not the case, or if you're having some problems with downloading them, you can use this type of methods. And then we've imported our data. So from here, starting from getting into the data, we're going to work with the raw data, the raw analysis ratings. So some exploration that you guys are familiar. So here we have different columns. What are the columns inside this data? We have one unnamed column, the headline, the URL, the publisher, the date stock, and heading the 10 part of the data. This is the first 10 part, or the first 10 data. And then now we can use this class as what we've imported lastly. So now, again, getting back to the data. So this class, we have like giving this class a data will just give every function. So since it is taking every values from the class using self, every function. So giving one specific data to article data analyzer will give that same data for the function called format data. So I have given this raw analysis data into article data analyzer class, and name data as analyzer. So now analyzer is same as the class article data analyzer, containing the data called raw analyst, right? So here, after now and all, we can just use the variable analyzer. While like every time we need specific variable to use from article data analyzers, so we can just use them. So from the analyzer, which is this class with this data, we have now we wanted to use this publisher analysis function. What is that? So the publisher analysis function will help us to visualize the number of articles per publisher. So from here, from the data publisher, it will count the value. So the number of articles. specifically for that publisher. And the top publisher here, from the publisher count, so taking this output, so we are hitting the 30 top publishers, right? So then we are visualizing this using Seaborn libraries. It is imported, so you can just rename, or you can just label the X and the Y values. You can do a different type of thing. So this functionality is defined inside the publisher analysis function. So now we can just import the publisher analysis function without any data, because we are just using the analyzer variable, right? So we are just indicating the name. We're just indicating the name called the data called raw analysis. So running this again, we can just do it here. So it will just it will just return the number of articles per publisher. So these are the name of the publishers, and this is the number of articles. So name of publishers and number of articles are the names that are labeled for the X label and for the Y label, Y protein. So everything is from there, right? So we have just used the publisher analysis, which means we can just go and use, imagine if we don't have this type of labeling, because now we know the data, but for the rest of them, and also for the column name here, this is what we call, like, if you have the same data and you want to do another analysis inside another notebook, you can just use this function called publisher analysis. So no need to do or define these functions every time you need to use it. So here we have plotted the number of articles per publisher and the publisher needs. Okay, so the number of publishers here are what? 30, right? So because we have we are using the top publishers, which is heading the 30 data from the publisher counts, right? So this is the data that we have indexed for the X and the Y. So yeah, from all the publishers, we've chosen the 30 publishers. Actually, not just, but we have counted the 30 top publishers. So here we have used the publisher analysis. So the point is how we have used the function called publisher analysis from a module called sentiment analysis. Okay. This is for financial forecasting. And what about for quantitative analysis, or specifically for Apple historical data? Also here we've done the same, adding the root directory and then importing the important libraries. Also here we have imported some scripts from scripts, quantitative analysis module. We have imported the class called quantitative analysis. So here again, giving any type of data here, we'll just pass it for every functions defined here, okay? So from these functions, what we have used, what we have decided to use is the plot stock price. Let's see. Now also some ED, like this is a really simple ED, so you're expected to do different type of EDs or the major EDs. So we've just, here we have printed the shape of the data, which is 10,998 rows and 9 columns. And then we're trying to check if the sum of the empty values inside every column. So there is none, which is a very good thing, I guess, for you. So now we have just the same thing we did here, okay? Quantitative analysis. For the class quantitative analysis, we have used the data. So like here you can see that we have imported the data, we have read the data in the CSV data into a data frame using Panda, right? And then we have given the variable name called Apple. So after this on, while trying to indicate for this Apple historical data, we're just going to use the name Apple. So here we have just used this Apple. It's now Apple is name of the data. We're indicating for that specific data, and we have renamed data for this renaming. This is just a string, so you can just change it for whatever you want. So now our planning and analysis using the Apple analysis variable is just the same as using the quantitative analysis class with your data. So like change data to time. So first let's do the renaming. And using this specific Apple analysis, I changed date to time variable. Let's see, is not bringing anything because it is not stated to print anything. Going to the function here, change to data time, it would just convert the dates column to a datetime format, but we're not printing anything. There's nothing happening, so there will be nothing here we can see. What about the plot? What is the, like, here is the plot. We can just run it again. So plot stock price. What are we doing here? Let's see. So here we are creating line of plots, two type of plots, okay, showing the price components. So like the first is like the date, the open, the high, every column. So we're just trying to take different type of colors: blue for one, green for the other, red for the other, and black for the other. The alpha will just okay. The alpha will just give the strings or the intensity of the colors. So you need to check how to do different plotting. So here we're just trying to plot. The first one is the data and price plot. Okay. So what we have got is running this again. It has just run. So yeah, so for the high, for the low, and for the close, for the three different colors, you might not be able to see this. Like, so there are different, there are all the colors here. Maybe it is somehow hard to see. So we've labeled it to date and the price. So let's go to our function and see what is happening. So X is for the date and Y is the price. So it is stating, okay, the date of specific, the date, and for that date, the amount of stock market, the amount of price that the stock market was sold for. Okay, so like this is the first graph then. So what other thing do we have is the MPA plot. So we're not just plotting one, we're not just putting one plot, but we're also using the candlestick chart, which is more technical chart. So it will help us to visualize the same data in different formats. So here we have the candlestick chart of Apple, which is, because this is the title that we have given it here, okay? So the Y label is price, and the style is Charles, the type is content. So every information that is needed for the graph is just done there. So it will give us a more specific, actually, like this is more used for the technical use, since it is divided into a grid, but nothing different. It is just a different format. So the point is, we'll also use the specific function called plot stock price in order to, which is defined in our module, in order to do this graph, okay? So the main thing that we have done here is, like, in order to start from the basics, so we have just created our virtual environment, and then we have created our notebook. So like if there's a specific thing that you wanted to include inside the notebook, okay, this can be built as a function. So we will get back to our source or to our script folder, then we can just put the function name here, the function description, everything here, and we will just import it here. So while doing this thing, if there's some modules, libraries, the standard library that we have used, we need to just go to activate our virtual environment and install everything here. So we have used, if you can see here, we've used different type of pip installs in order, after creating our virtual environment here, okay? So the other thing is the same virtual environment. Since we are on Jupyter Notebook, we need to select kernels before starting everything. Here you can see that there's clicking this, you can just use select another kernel or the specific kernels. So now, since I am using the new virtual environment that I have created, that is why this is appearing on the top as one of the top virtual environments, but you can choose from different Python environments that you've used before, okay? So activating your virtual environment, it will ask you to install Jupyter, then you can install Jupyter kernel here and continue with your process, okay? So now let's start. If you have any question, okay, Nabil, you can go.
I was going to ask, generally for my Jupyter notebooks, because it's kind of where I clear up my ideas. Instead of writing modular code for my Jupyter notebooks, I just write the code, I just do really quick testing. And then later on for my final code, I make it properly modular. And then I'll have my main.py in my run pipelines. That's how I generally work through my development process. Is that a bad practice? Is that a good practice? What are your thoughts?
No, actually, as I have mentioned, so like while mentioning the process or the procedures that we need to follow, I have just started from the notebook or from your Jupyter notebook. So I've just said, since, It's not like you decided what type of functionalities or what type of methods that you're going to use from the beginning and just applying them. So it is, you're going to discover things while working on, so you can just start from your notebook, but at the end, okay, this, this functionality is something that needs to be modular and that is going to be used by other projects, by other, like, not even other projects, specifically in this project, by another, in another place. So instead, or in another notebook again. So instead of defining these functions in every notebook that I need to apply this functionality, so I will prefer to put them in a script, so then I can create a script. So it's really valid to start from the notebook and then go to the modularity part.
So what I'm saying is, if some of our notebooks are non-modular, but our final code in our repo is modular, is that okay?
Yeah, like now, from what aspect are you asking? From development aspect, or
like
from the assignment?
From even from an assignment aspect. If you look at my notebooks, and my notebooks themselves are non-modular, but then the final code in my repo that are supposed to run, if that is modular, and my main.py and all my source modules are all modular, but my notebooks are not modular, is that okay?
No, it is not. I mean,
everything should be modular. Everything should be modular across the board from now on.
Yes.
Okay, just wanted to make sure.
Okay. Thank you, Nabi, for asking. Is there any other question? Actually, is there someone, like, let's proceed for another questions, because I would definitely expect questions. Red, okay. My video was breaking. I'm sorry, I haven't checked for this comment. So, you guys, so like, now we need to participate. So was that clear, or was that not clear? Or was that some, common concept that we have already understood? What is the deal? Okay, Petros, thank you. What about the others? Okay. Okay, but also for one last time, maybe in Hawaii. So ጥያቄ ካላችሁ any type of ጥያቄ ካላችሁ ጠይቁኝ እና ኤክስፔክት አደርጋለሁ ጥያቄ እንደሚኖራችሁ። ሶ ፊል ፍሪ ካልገባችሁ ያልገባችሁ ፓርት ካለ ምንም እንትን ታይኒ ጥያቄ ቢሆንም ጠይቁኝ። ሶ ኤቭሪዋን ከገባችሁ ደግሞ you can show thumbs up emoji. You can just show me. Okay, then I will consider it like you have understood. Thank you everyone for being here. I will just Shamda Mikhail, you can go on.
ግልጽ እንዲሁም በአማርኛ ላውራ ይቻላል?
ይቻላል።
ያንቺ ስትራክቸርን ሳየው ለትልቅ ለኛ ከተሰጠን ስትራክቸር ትንሽ ይለያል፣ ግን ያው አፍተር ኦል ስትራክቸሩን ስናስብ እኛ በምናስበው ሁን አይደል ኦርጋናይዝ የምናደርገው as long as modular እስከሆነ ድረስ። ይሄ ጀስት ለኮንፊርሜሽን ነው። ዋናው ጥያቄ ያንቺን ኖትቡኩን ሳየው የፋይናንሻል ፎርካስቲንግ ኖትቡክ አለን፣ የኳንቲቴቲቭ አናሊሲስ ኖትቡክ አለን። የተሰጠን ዳታ ደግሞ ኦልሞስት የካምፓኒዎቹና ፕላስ የዜናው ዳታ ተሰጥቶናል። እዚህ ጋር ያው ለጊዜ ለእንትን ብቻ ነው እንድትጠቀምሽው። አሁን ለዚህ ለተሰጠን ቻሌንጅ ለእያንዳንዱ ካምፓኒ ኢዲኤ መሰራት አለበት አይደል? ስለዚህ ያንተኑ ላይ ኖትቡኩ ላይ የሁሉንም ኢዲኤ ስቴፕ ባይ ስቴፕ እየሰራን ማሳየት አለብን ወይስ እንዴት ነው?
Yeah, I mean, so like the first part is IDE መሰራት አለበት የሚለው. So if you believe that the IDE part include መደረግ አለበት ብለህ ካመንክ, then so it's a notebook, and a notebook at a time ስለ አንድ ነገር ዲስከቨር ቢያደርግ or cover ቢያደርግ is encouraged. So if you are going to do an IDE for all the companies that is given, then the best practice to do is notebook actually ለአራቱም ካምፓኒ ስፔሲፊክ የሆነ ኖትቡክ ክሬት አድርጋችሁ ቪዲዮ የምትሰሩ
ማለት እዚህ ጋር አሁን አሪፉ ነገር የስክሪፕት ፓኬጅ ላይ ለኳንቲቴቲቭም ለሰንትልመንቱም አናሊሲስ እንትኖች ሞጁሎች አዘጋጅተናል። ስለዚህ ላይ ሄደን ለእያንዳንዱ ካምፓኒ የራሱን ኢዲ ከሰራን በኋላ መጨረሻ ላይ ያንተውን ለቴክኒካል አናሊሲሱ ራሱን የቻለ ኖት ቡክ ያስፈልገዋል ወይስ ለማወገር ስላለኝ ነው?
So like there law የለም by the way. I mean እኛም like in the assignment so in the development wise so there is no law in እንዲያርገ ያስቀምጥ አለብህ so የሚል so like አሁን ለምሳሌ let's assume like specifically for me if the area that you're going to do ለእያንዳንዱ company is ዝም ብሎ ኮለሙን ማሳየት ለሁሉ let's imagine እንደዛ recommend አላረግህም ለእያንዳንዱ ካምፓኒ አዳዲስ ኖትቡክ ክሬት እንድታረግ so you can just include them on ሁሉንም አንድ ኖትቡክ ላይ just exploring the data ብለህ EDA for every company ብለህ include ማድረግ ትችላለህ so and then እነሱን ካምፓኒ ተጠቅመህ sentiment analysis like ዴታቸው ላይ የሆነ ነገር ኢንፈርስ ታደርግ or actually to the development ስትገባ ደግሞ ለብቻው ክላሲፋይ አድርገህ ኖትቡክ ላይ ዴቨሎፕመንቱን መስራት ትችላለህ okay since the type of development that we are working on is predict ማድረግ ዳታን ቪዥዋላይዝ ማድረግ ዴታ አናሊሲስ ማድረግ so we expect you to ለዛ ነው ኖትቡክ ኤክስፔክት የምናደርገው እንጂ usually ስክሪፕት ነው አይደለ ዴቨሎፕመንት የሚሰራው so እሱ ላይ ስትመጣ ደግሞ you can just create your own notebook ማለት ነው so law የለም it depends on the amount of EDA that you can do you know common sense ሊኖረን somehow ልንጠቀምም እንችላለን okay ግን depends on the type of EDA that you're going to ግን ያው basically for the technical part way to the real environment to the prediction to the comparison correlation አቸውን check ማድረግ ምናምን ስገባ I would expect you to see another to use another notebook if I get your question right
ሌላ ሁለተኛው ጥያቄ ከእንትን አስቀምጡ ከተባሉናቸው ፎልደሮች አንደኛው የዩኒት ቴስት እና ሌላኛው ደግሞ የሲአይሲዲ ዩኒትን እንዴት ነው እንጠቀምባቸውን በዚህ ዊክም ማለት ዲፕሎይ የምናደርጋቸውን ነገር እያየው ስላለነ ነው
ኦኬ ዲፕሎይ የምናደርጋቸውን ነገር ይሰይድ
ማለት አሁን የጊትሃብ አክሽን ብለን የሜል ፋይል ምናምን አስቀምጠናል ግን ለሱ ምንም አይነት ስክሪፕት ምናምን የጻፈን አልመሰለኝም የባለፈው ላይም ፌል የሚያደርግ ነገር ነው ያሁኑን አስፈላጊ ነው ወይስ just
so for every week እንትን ነው ዶክመንቱ ኢፍሬዝ የሆነ አዲስ ነገር ዲፕሎይመንት ከሆነ ዲፕሎይመንት ከሌለው እንትናችሁ ላይ ዲፕሎይ አታረጉም ቴክኒካል ዶክመንታችሁ ላይ በቃ ዲፕሎይ አታረጉም so the basic ሁሉ ጊዜ ደግሞ አዶፕት ማድረግ አለብን የተባልናቸው ሜትዶች we need to keep using those methods አሁን like every week ላይ make it modular make it እንደዚህ CICD ተጠቀሙ ምናምን አትባሉ now there are the basic things that we always expect you to do እና ደግሞ there are some things that we will expect you to do if it is mentioned on the technical document ለዛ deployment and other እንደዚህ አይነት ፋክተሮች or in the task የሚቆጠሩ ነገሮች if they are not included on the document then they are not ግን unit test ካልከኝ አሁን unit test is not እንደዚህ unit test ተጠቀሙ ተብላችሁ የምትነገሩት ነገር አይደለም or specify የሚደረግላችሁ ነገር አይደለም unit test so I have not included it here because I felt like there was a class ከዚህ በፊት unit test ላይ or there will be if it is not if አሁን ከሌላ or which it could have been included then so unit test ላይ specifically in order or task ላይ ጣላችሁ ይችላል you just need to include it so እነሱን ታስኮችም ለየታል እሺ thank you Michael for asking any other question so here as a hint ሌሎች ኤክስፔክት የምትደረጉት ነገር ለመስራት ኤክስፔክት የምናደርጋቸው ነገሮች they're also included ግን ያው ዋናው ሞጁላሪቲ ፓርት እንድትያዝ ስለተፈለገ ሌላ ጥያቄ ያለው ሰው አለ you guys thank you for being here ምንም ጥያቄ ካላችሁ ያው try to reach out on Slack and also on our group like individual group ላይ reach out ለማድረግ ሞክሩ Thank you for being here. Bye, guys.